Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. I'm so glad that you're joining us. Thank you so much, Dr. A. I am so glad that you're here with us for Wednesday night math. Now, I know that a lot of you are going to be preparing for different exams. So the first thing I want to do is let me know in the comments, what test are you preparing for? So what test are you preparing for? That's going to better help me structure my conversations with you guys. Hi, Callie. I'm so proud of you for passing that Feely, and congratulations on your assistant principal job. If I could give you a high five through the screen, I would. So what math exam are you prepping for? GK, FTCE 7 through 12, K through 6, which one? Hey, Monique, which FTCE exam are you preparing for? Are you preparing for K6, pre-K through 3, GK? Awesome. It looks like we have a variety of people in this Wednesday night math session. I'm so excited to see all these new faces. All right, I chose to wear my red, white, and blue shirt today because the Olympics are on, and I am a sucker for the Olympics. I love watching swimming and gymnastics and basketball, all the things. So another fun question, what do you like watching on the Olympics if you watch the Olympics? So that's why I'm decked out in red, white, and blue today. So, all right, it looks like we've got some variety of friends in here. Let's get started. Let's not waste any more time. Let's get started with our first problem. Like Dr. A said, I have 10 problems prepped. There are some weeks where I get to all 10, and there's some weeks where I don't. I highly, highly, highly encourage you, use the comment section. If I'm going through a problem and you're like, whoa, wait a minute, I don't understand that. Can you go back? Please comment. I will be reading the comments as I am working through these problems. So please comment in the comment section and let me know. Vicky's favorite is ping pong, track, and diving. For those of you who are just joining us, Throw in the comments what you love to watch on the Olympics. That's why I'm wearing red, white, and blue today. And let me know what test you're preparing for. All right, first problem is patterning. Now, patterning like this is going to be on a pre-K through 3, K through 6 exam. However, it's important that we all understand patterning because patterning is seen among functions, which is what you're going to be using in any 6 through 12 exam. GK, Core, Praxis, 7 through 12, all of it. So patterning is super important. The reason that our students learn patterning in elementary school, pre-K through 3, K through 6, is because they need to be able to see those patterns so that they can apply them to functions later. So let's take a look at this and then take a look at what those patterns are that I'm even talking about. So Monique likes track. That's awesome. I do like track. I wish I could be a track star. All right. Which of the following is the 38th shape based on the pattern above? Which of the following is the 38th shape based on the pattern above? So we see that it starts off with a triangle in the top, and then it goes to the next triangle on the right, and it kind of goes in a clockwise manner. So we're going 1, 2, 3, 4, and then once we're all filled in, then we start filling in the other triangles. 5, 6, 7, 8. So here's what we could do. I could sit here and count out to the number 38. 1, 2, 3, 4, 5, 6, 7, 8. This one is the same as this one, so I'm just going to not even use that one. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Winner. Letter D is the answer. But here's the problem. What if it said which of the following is the 238th shape based on the pattern above, or 167th? Ain't nobody got time to sit here and tally mark until, eternity. So how else could we solve this problem without sitting here and counting? Well, what I want you to notice is how far does the pattern go before it repeats? We have 1, 2, 3, 4, 5, 6, 7, 8 objects before it repeats back to the first one. So what we can do is take the number that we're looking for and divide it by 8. That's going to show us how many full pattern cycles we're going to have. So 38 divided by 8. When I do 38 divided by 8, I know that 8 times 4 is 32. 8 minus 2 is 6. What does that mean in the context of patterning? That means that I have 4 full pattern rotations. Let me show you that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's 4 full cycles with a remainder of 6, which means I'm going to land on the 6th pattern because I had 4 full rotations. So 1, 2, 3, 4, 5, 6 is my answer. Let's try another one. Let's try one that we can't count out. Let's say which of the following is the 272nd shape based on the pattern above. What would we do? Well, we would divide 272 by 8 because we have 8 items in our pattern before it repeats. 8 goes into 27 3 times, 24. Of course, I picked an answer that's divisible by 8. I did not do that on purpose. 8 goes into 32 4 times. That means that we don't have a remainder, which means that literally the 272nd shape would be the 8th shape because that's the end of my cycle. So that would be my shape because it doesn't have a remainder. So I'm going to land right there. All right, why is this important? Well, because then as they get older, we start looking at X and Y relationships. Middle school and high school teachers, this one's for you. So if you kind of tuned me out because you were like, this is on an elementary exam, this part's for you. They need to start to be able to recognize patterns between numbers. So if I gave you -1, 0, 1, 2, 3, And then I gave you this, and I said to them, what is the pattern that you see? Students should be able to see that pattern, which is why understanding these kinds of patterns is super critical. All right, let's move on to the second question. Remember, if you have any questions, drop them in the comment box so that I can go over them as we're sitting here. Also, if you have any questions that you're like, you know what, I was working through my boot camp, or I was working through my study materials, and I really don't understand this question, you can throw that in the chat box. No guarantees I'll get to it today, but I will add it to my list of problems to do next week. If you have concepts that you want me to go over, you can do the same thing. All right, if you were with me last week, we went over a problem similar to this, but this was something that we struggled with, so let's do another one. If I have a dog, then I am wearing purple. Does that even make sense? No, that doesn't make sense. If I have a dog, then I'm wearing purple. Fun fact, I do have a dog, and I'm not wearing purple. But this is important for you to realize. 9 times out of 10, when they are doing statements like this, inverses, contrapositives, positives, all of that, oftentimes they will use statements that don't make sense in hopes that you will pick an answer that makes sense, and it will likely be wrong because you're not using your understanding of deductive and inductive reasoning, your understanding of contrapositive, converse, and inverse. You're using your normal brain, as I like to say it, your brain that tells you what makes sense, and we don't want to do that. We want to understand what inductive and deductive reasoning is, and we want to understand what contrapositive, converse, and inverse mean in the context of these problems. If I have a dog, then I'm wearing purple? Probably not true, but we're going to move forward with it anyways. Which of the following would be the converse statement to the statement above? Well, they could ask you one of 3 things. Converse, but they could also ask you for the inverse. They could also ask you for the contrapositive. That's a word. Contrapositive. And they can also ask you for the converse. What do these even mean? Well, these apply to if-then statements. So I'm going to move this over here so that I can write with it. If P, whoops, I don't know what that was. If P, then Q. That's my original statement. Now, if I take that and I apply it to inverse, contrapositive, and converse, the converse to if P, then Q would be if not P, then not Q. So if this is my statement, if P, then Q, the inverse is going to be if not P, then not Q. The contrapositive is going to be if not Q, then not P. And the converse statement is going to be if Q, then P. So knowing that, which answer is going to be the converse? Let's take a look at each answer and kind of decide and label them. If I do not have a dog, then I am wearing purple. Well, dog is my P. So this is my P and then this is my Q. Uh-oh, did we lose the feed? Yes, we did. We lost the feed. All right, let's try this again. So we're talking about contrapositive, positive, and contrapositive, converse, and inverse. And give me 1 second to reconnect my slides here with you guys. As Dr. A just commented, if you want these slides to practice later, feel free to email the email address that you see in the comments. So while we're waiting for my computer to reconnect, if you want the slides, go ahead and email Dr. A at that email address. All right, so this is P. This part is Q right here. So if I do not have a dog, then I am wearing purple. So we have not P, but Q. Do you see that anywhere in our options up here? No, that's not even a choice. So A is not even anything. B, if I am wearing purple, so that's Q, then I have a dog. That's P. Well, if Q then P, that's converse. That's what we're looking for. So B is the correct answer. If I am wearing purple, then I have a dog. Ashanti, excellent job. If I could give you a high five through this screen, I totally would. I see that you commented that as the answer. If I do not have a dog, so not P, then I am not wearing purple, not Q. What would we call that? Not P, not Q. That would be our inverse. Excellent job. High five. If I am not wearing purple, so not Q, then I do not have a dog, not P. What would that be? That would be our contrapositive. Excellent. Obviously, if I was taking this test, I would not take all this time to do this, but I want you guys to understand what each of these answer choices is. So if it didn't say what would be the converse and it said what would be the contrapositive, you would know what we're dealing with. All right, let's move on to problem 3. Again, if you want those slides, drop a comment. Well, you don't have to drop a comment. Just email Dr. A at jampel@thelearningliaisons.com and he'll be happy to give you these slides. Not with my notes on it. I'm so sorry, but you will get the slides with the problems because it's already 7:20 and I'm not going to finish all 10 problems. So if you want extra problems, email him. All right, problem 3. The test scores for 5 of the 6 students in Mrs. Klein's math class are shown below. If the average score of the test was 82% for her entire class, what was the 6th student's score? So what do we have here? We have average. We have the mean. Average and mean are the same thing. Average, mean, same thing. I like to think of the mean because sometimes people get the mean, median, and mode confused. I like to think of the mean as being very mean because it makes us do a lot of work. So we have to add all of the data points up and then divide it by the total number of data points that we have. So let's go ahead and take a look at what we have. We have 5 scores, but there's 6 students in her class. So how are we going to do that? Because we're looking for that 6th student's score. So what we really need to do is think about how to add that student's score in. We have 68 plus 84 plus 91 plus 75 plus 74 plus X. That's the 6th student's score. But how do we find average? We add them all up. And then we divide by the number of data points that we have. How many data points do we have? 1, 2, 3, 4, 5, 6. We should have 6 because there's 6 students in the class. That equals what? All of that is our average, and the average equals 82. They gave us that information, which is awesome. So all of that is going to equal 82%. Now, what are we going to do? How are we going to unlock that X from X jail? Because really, this X is trapped in numerator jail, and we have to let it out. The first thing we have to do is multiply both sides by 6. Again, if you have questions while I am going through this and you don't understand something, please comment in the comment box. Multiply both sides by 6. Now I'm left with that numerator. Now, some of you are going to be allowed a calculator on your test. Some of you are not going to be allowed a calculator on your test. I'm going to go ahead and just add everything up in my calculator because I don't want to make a silly error. So 68 plus 84 plus 91 plus 75 plus 74. That equals 392 plus X. And my numerator was unlocked from numerator jail. And that all equals 82 times 6. Now, you're wondering, will I see this on my test? Pretty much Any elementary through high school could see this. K through 6, you're going to see it. Middle school, you're going to see it. GK, core, 7 through 12, you're all going to see it because this falls right in that like 6th, 7th, 8th grade range. But my elementary teachers, it falls in that 6th grade range just enough that it could fall on your test. And knowing mean, median, and mode and measures of central tendency really stretches across most of the assessments. So this is important for everyone. All right, how do I find X? Subtract 392 from both sides. So X equals 100. That means that the 6th student's score is a 100. Good job, 6th student, for getting 100 on your test. All right, let's keep going to problem 4. Does anybody have any questions about what I've done so far? Let me know in the comments if you have any questions on what I've done so far. I'm going to move on to question 4. This is a pretty straightforward question. It's about shapes. Which of the following best describes the shape to the left? That's actually the shape below, but, you know, minor details. So we've got a regular octagon, a regular star, a convex octagon, or a concave octagon. So this does look like a star, kind of, but when they're asking for a description of a shape, it's important that we use geometry terms. So let's count the number of sides on this shape. 1, that's an eraser. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided shape. What is an 8-sided shape? An octagon. So we have some sort of octagon here. Is it a regular, a convex, or a concave? Well, here's what we know about a regular shape. Regular hexagon, pentagon, octagon, whatever. A regular shape is going to have equal angles, equal sides, and it is going to be a convex shape. So a regular octagon is going to be a stop sign. It's going to look something like this, and we're trusting my ability to draw equal sides here. It's the best I can do. That's an attempt at a regular octagon. So it's not a regular octagon. What do we know about convex and concave? Convex is going to be a shape that looks like a balloon. It's been blown out. A concave shape has caves in it. That's how I remember it. A concave shape has caves that a bear can hide in. There's my elementary teacher and me coming out. So a concave shape has caves that a bear can hide in. This shape has no caves. It's blown out like a balloon, which is a convex shape. This shape has caves in here, right here, right here, right here, and right here. So this is going to be a concave octagon. Let's practice another one, like contact lenses. So a contact lens, it's going to depend on which direction you're looking at them from. That's a really good question. So like if you're looking at it like this, that would be convex because it's out. But if you're looking at it like this, that would be concave. So that's kind of an interesting one. Let me draw another shape, and I want you guys to comment what kind of shape this is. So I'm going to switch colors. What kind of shape is this? What kind of shape is that? I might have tricked some of you. Give me a comment in the comment box and tell me what kind of shape that green shape is right here. There's a couple of different ways you could identify this shape. So don't be afraid to like answer because you're afraid you're going to be wrong. What kind of shape is that green shape right here? Like I said, there's a couple of different ways we could identify that shape. A trapezoid, okay. That's one way we could identify that shape. A rhomboid, okay. I was hoping someone was going to use the vocabulary we just used. If someone wants to be bold and try to use convex or concave to identify that shape, that would be awesome. Yes, let's talk about trapezoid while I wait for someone to like comment about what kind of shape this is. This is a trapezoid. Why? Because it has exactly one pair of parallel sides. This side, I'm going to switch colors for you. This side is parallel to this side, which makes a trapezoid a trapezoid. So we could call this a trapezoid. We could also call this a convex quadrilateral. Now, you would probably never see it labeled like that. You would probably see it labeled as a trapezoid, but this is a convex quadrilateral because it has 4 sides. A quadrilateral has 4 sides. An octagon has 8 sides. A pentagon has 5 sides. And it's convex because there's no caves where the vertices are. A bear couldn't hide here, 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 or here. Those caves are going to happen at the vertices. So this would be a convex quadrilateral or a trapezoid. All right, let's move on to problem 5. A rectangular playground is built using 100 yards of fencing. The width of the playground is 2 more than twice the length of the playground. About how many square feet does this fence contain? This problem is going to be seen K-12. I'm trying to use problems that most everyone would see because this is an area problem and it's an expression problem and it's a conversion problem. I encourage you to know if you get a reference sheet or not because those reference sheets are going to be helpful for some of you. So, rectangular playground. I'm going to draw a rectangle. Rectangular playground. All right. What else do I know about this shape? It has 100 yards of fencing. That means my perimeter is 100. Because perimeter tells us how much around the shape we have. So this is perimeter. Our area is going to tell us how much grass or mulch or whatever can go in the playground. So perimeter is outside, area is inside. So our perimeter is 100. And what is it asking us to figure out? It's asking us to figure out about how many square feet does this fence contain. As soon as we see square feet, we know that we're looking for our area. Why are we looking for our area? Because square units indicate that we're looking for the area of a shape. Linear measurements, perimeter and stuff like that is going to be just feet or yards. Area is going to be square feet, square yards, square inches. And volume is going to be cubic feet, cubic yards. So we're looking for the area of this shape. Problem. We don't know what the length and the width is, and area equals length times width. But what information did they give us? They told us that the width of the playground is 2 more than twice the length of the playground. That right there is going to cue us in to what we can do to try to find this perimeter. So I'm going to literally take that sentence and translate it. The width is equals. When you're translating algebraic expressions or equations from words into symbols, you can pretty much count on the fact that is means equals. The width is 2 more than something plus 2 twice the length. 2 times the length. Now, some of you are asking, why did I do something plus 2 and not 2 plus something? Excellent question. I'm going to answer that when I'm done solving this problem. So if you're wondering why I did something plus 2 and not 2 plus something, I will answer that at the end of this problem. So the width is 2 times L plus 2. Well, what does that mean? If that's W and that's L, and that's L and that's W, I can substitute or replace my W's with 2L plus 2. Because what does an equal sign mean? An equal sign means the same as. So if W is the same as 2L plus 2, then I can replace the W with 2L plus 2 and 2L plus 2. Now I can add all of those up to equal 100. So L plus 2L plus 2 plus 2L plus 2 equals 100. I did this side plus this side plus this side plus this side equals 100. Let's go ahead and add all of our L's together, because keep in mind, you can only add things that are alike. So you can only add the L's together and then the other things together. So 1, 2, 3, 4, 5, 6L plus 4 equals 100. Subtract 4 from both sides. 6L equals 96. Divide both sides by 6, and L equals 16. All right, I know L equals 16. Well, what is W then? Let's take that 16 and plop it into our W formula. W equals 2 times 16 plus 2. 2 times 16 is 32 plus 2 is 34. So the W is 34. Whew! All right, what do we have now? We have our length and our width. And if I multiply my length times my width, 34 times 16, I get 544. But that is the wrong answer. Why is that the wrong answer? Why is A not correct? Does anybody have a guess as to why A is not correct? Let me know in the comments if you have a clue as to why A is not correct. When we look at the problem, the playground was built with 100 yards of fencing, but it's asking us for how many square feet of fencing. So unfortunately, this is 544 yards squared. We didn't convert. So we have to convert. We know. Good job, Ashanti. Good job. I don't know what your name is, but good job. All right, we know that 1 yard equals 3 feet. So we can convert this by multiplying everything by 3. So 16 times 3 is 48. 34 times 3 is 102. And now I can do 48 times 102, and I get 4,896 as my correct answer. Now, some of you were wondering why I did something plus 2 and not 2 plus something. Let's talk about that real quick. Why did I do, and I'm going to duplicate this slide so I don't run out of space here and erase all of this. Why did I do something plus 2 and not 2 plus something? Now, with addition, it doesn't matter. So we had 2 more than twice the length. So I did something plus 2, which turned out to be 2L plus 2. But you're wondering why I didn't do 2 plus 2L. Now, again, addition is commutative, so it doesn't matter in this specific case which one I do. But it does matter when it's subtraction. Let's go ahead and change those words a bit. 2 less than twice the length. Now it does matter. Now, 2L minus 2 and 2 minus 2L are very different things. 8 minus 4 and 4 minus 8 are not the same thing. So how do I know when to do something plus 2 or 2 plus something or something minus 2 or 2 minus something? Well, I like to think of it in real world terms. If I have 2 less than 7, if I said what is 2 less than 7, what would you tell me the answer is? 5. 2 less than 7 is 5. We all know that. What did we do to solve that? We did not do 2 minus 7. We did 7 minus 2. So when you see something less than or something more than, what it actually means is something plus 2 or something minus 2. It is not 2 minus something. I hope that makes a little bit of sense and that clears up some confusion on converting algebraic words into expressions. All right, let's go ahead and do a problem for our pre-K through 3 folks. So if you are preparing for a pre-K through 3 assessment, symmetry is on your assessment. Now, I always like to add at least one specific question for our pre-K through 3 people because their test often does overlap with our K through 6, but there are some very specific topics on that pre-K through 3 test that are not on any other test, like symmetry. So, which letter does not have horizontal symmetry? Horizontal symmetry means I can cut it horizontally. So this is horizontal. And this is vertical. Everybody needs to know that because you need to know which direction your axes go when you're graphing. So which letter does not have horizontal symmetry? So if I cut the letter T, and I'm going to draw it a little bigger, horizontally, are they the same on the top and the bottom? They're not. Does the letter T have symmetry? Yes, it does. If I cut the letter T up and down vertically, it does have symmetry. But they didn't ask us for any symmetry. They asked us for specifically horizontal symmetry. So we've already found our answer, but let's explore all of the other letters. H. If I cut the letter H horizontally, the top is going to look like the bottom. What about the letter D? The top looks like the bottom. And what about the letter E? The top looks like the bottom. So the letter T is the only letter that does not have horizontal symmetry. Let's talk about vertical symmetry. Which letter is the only letter that does not have vertical symmetry? I'm going to let you answer in the comments. Which letter is the only letter that does not have vertical symmetry? Oh, it's not only. There's multiples of them. I'm sorry. D, so like the letter D doesn't have vertical symmetry. So let's explore that. D, when I draw a horizontal line there, the hump does not look like the straight line. And E, you are correct. I was thinking it was only E, but I was way wrong. E does not have vertical symmetry either. T and H do have vertical symmetry. Excellent job. All right. I'm going to move on to a problem that is very specific for my high school and middle school friends. So if you're taking a 6 through 12, a 7 through 12 math assessment, this one is for you. I did skip problem 7 because I want to make sure I have enough time to explain this problem. We'll go back to problem 7. All right. A particle is moving along the x-axis so that its position at time t is given by the formula S of t equals 3t squared plus 8t minus 2. What is the velocity of the particle after 3 seconds, and in which direction is the particle moving? Whoa. All right. This problem is very specific to my 6 through 12 or 7 through 12 people. This is a calculus problem. The first thing you have to understand is this. Your first derivative is going to give you your velocity function. Your first derivative is going to give you your velocity function. Your second derivative, or the derivative of the velocity function, is going to give you your acceleration function. Now, middle school math people and core praxis, core GK, you need to understand what shape this forms. So we will talk about that so that I can at least rope you into this problem as well. But for right now, I'm going to focus on those derivatives, but I will pull you guys in when it comes to discussing what shape that forms. All right, so if it's asking for the velocity, we need to find the first derivative of this function. So S of t equals 3t squared plus 8t minus 2. Finding the derivative of this is very easy. It's a very straightforward derivative for you. You're just going to use that power rule or the power derivative, whatever that's called, to find the derivative of this. So the way we do that is we drop the exponent, subtract it by 1, and multiply it by whatever our coefficient is. So we drop the 2 down to next to the 3. So 2 times 3 is 6. And then we subtract 1. 2 minus 1 is 1. Same thing on the next one. This is an imaginary 1. We drop it. 1 times 8 is 8. 1 minus 0 is 0, and anything to the 0 power is 1. So it just becomes 8. You cannot take the derivative of a constant. So that's it. That's the derivative, the first derivative, which is your velocity function. Now, if we needed to find the second derivative because it asked for the acceleration, we would use the same process. This is an imaginary 1. Drop it, multiply it by the 6. We get 6. 1 minus 0 is 0. So the acceleration function is literally S double prime of t equals 6. Acceleration function. Now, we didn't need to know that, but I wanted you to show you how to do it just in case. All right, so what did it ask? It asked what the velocity is of the particle after 3 seconds. So what am I going to do? T is time. I'm literally going to plug 3 into my velocity function. So S prime of 3 equals 6 times 3 plus 8. 6 times 3 is 18 plus 8 is 26. And it's a positive number, so it's moving in the positive direction. So B is the correct answer. You are not plugging 3 into the original function. That would give you the linear position of the particle, not the velocity or the acceleration. So, hi, Christina. I will answer your question in 1 second. Just give me 1 minute to finish up this problem. So, 26 is going to be the answer. It's moving in the positive direction. If we got a negative velocity, it would be moving in the negative direction. Now, for all of my middle school and high school people, let's talk about what shape that is. That is a parabola because it's squared. We know this is a quadratic function, which means it has 2 x-intercepts. So it's going to look something like this somewhere on that graph. It's important that you understand that shape and that as soon as you see something to the second power as your biggest power, that is going to be a quadratic function or a parabola. So, does that make sense, my high school people, how to find velocity and acceleration? I hope it does. Christina and all of our other new friends who have joined us, this prep is for any math exam that you might have to take for a teacher prep course, or for a teacher prep exam. This specific problem was for 6 through 12. I go through about 10 problems a week every Wednesday, and they are a variety of K through 12 prep. So I make sure that I cover the GK, the core, the math 6 through 12, the math K through 6, the math 5 through 9. I make sure that I cover a lot of the different subjects. And even if the problem is not related, like this is specifically for a 7 through 12 exam, I try to pull in my other people wherever I can by stretching it or pulling it down just so that everybody tries to benefit from every question. When am I going to convert the yards to feet, Hope? I already did that. I don't know if you're a little bit behind, but I already converted the yards to feet on the other problem. So if you want me to go back to that problem, I can at the end. Just let me know if you need me to go back to that problem. All right, problem Problem 7. We went to problem 8 so I could make sure I could get that calculus problem in. Let's go back to problem 7. Selah purchased a pair of jeans for $82 and a button-down shirt for $65. I tend to get very excited about math, so then I end up yelling, and then I end up losing my voice, which is what's happening right now. If he paid a total of $156.55, what percentage of tax did Selah pay? Very interesting question here. This is K-12. Anybody can see this on their exam. So there's a couple ways we can do this, and I'm going to solve it both ways. We can add up how much Selah spent. So Selah purchased $82 pair of jeans, $65 shirt. 82 plus 65 equals $147 before tax. That's how much Selah spent pre-tax. So I could sit and do what is 147 times 0.06. Why did I do 0.06? Because I can't just multiply it times 6. I'm trying to figure out what my sales tax is going to be. So I'm going to move that decimal place. When I convert a percent into a decimal, I hop that decimal place 2 places to the left. So 1, 2 gives me 0.06. 147 times 0.06 is $8.82. Add that to my 147, and I get $155.82. Not the right answer. Let's go ahead and do the 6.5. Now, here's a little trick. Rather than just multiplying it times the 0.06 or the 0.07 or whatever, if we multiply it times 1.06, we actually get the total. We get the tax plus the number. Let me show you. 147 times 1.06 equals $155.82. How cool is that trick? All right, so let's do that for this one. 147 times 0.06, 1.065. 147 times 1.065, $156.55. Bingo! There's our answer. Now, if you're more of an algebraic thinker, you don't want to use the answer choices to help you, which this is the way I would solve it. But again, I recognize that we all are different learners. This is how I would solve it. If I know that my total is $156.55, I know that I need to take my cost of my items times 1 point tax, right? Or times my tax. So I know that I'm doing cost times 1 point tax. Well, my cost is 147 times my tax equals 156.55. Divide both sides by 147. And I get 156.55 divided by 147, 1.0649, and I'm going to leave it there. What does that mean? That means that this right here is my tax percentage, which is 6.5%. So 2 different ways to solve this problem, but both are very valid and correct ways. I just want to let everybody know who's new into this room that if you want these slides, like maybe you came in late or maybe you are, cooking dinner while you're trying to prep this. If you want the slides, email Jason, Dr. A, and I'm going to go ahead and post his email here in the comments. Again, if you want the slides, you can I can't talk and type at the same time. You can email this email address and he will send you the slides from tonight. So if you want the slides from tonight, go ahead and email him and he will be happy to get those to you. Another little note before I go into the next problem, if you have questions that you want me to answer next week or the week after in my Wednesday sessions, let me know. If you're like, you know what, I really struggle with geometry. I really struggle with algebraic expressions, or I really want you to solve this problem, drop it in the comments and I'll be happy to add it to my list of things that I will cover in the next couple weeks. All right, problem 9. A ball is thrown up from the top of a building and is represented by the function h of t equals negative 16t squared plus 5t minus 34. Your brain should already be firing that you know what shape this is because we just talked about this, that this means it's a parabola. Moving on. Which of the following values represents the maximum height of the ball at a certain time? The x-intercept, the y-intercept, the y-coordinate of the vertex, or the axis of symmetry? Well, we know it's a parabola. We also know it's an upside down parabola because this value is negative. So if I were to draw this, I'm standing at a building, I throw the ball up, and it comes down. Why did I only draw that part of my parabola? Why didn't I draw my whole parabola? Great question. Because this is the time, and this is the height of my ball, and my ball isn't going to go into the negative depths of the earth, and my time can't be negative. So I'm starting with time 0, and I end at when the ball hits the ground. It's not going to be a lava ball that drives into the ground. So that's why I'm stopping. It's asking us which value represents the maximum height. Well, the maximum height is right here. Maximum should immediately cue you in to vertex. And the only answer choice here that includes vertex is C. Now, if they said the x-coordinate of the vertex or the y-coordinate of the vertex, that would be tricky. The x-coordinate of the vertex would give us the time of the maximum height. The y-coordinate actually gives us the height. The axis of symmetry is actually the x value. So let's pretend that this value is, actually I could find it, but we're going to pretend right now because finding it is going to take a hot minute. Let's pretend that this value is -2 or +2, 8. The axis of symmetry would be x equals 2. So it's not going to be the axis of symmetry because that would be x equals 2, and that doesn't give us the maximum height. The maximum height is that y coordinate. So that's why C is the correct answer. I'm actually going to erase this because that is not the actual vertex of this equation. So unfortunately, we do not have time to get to problem 10 because Dr. A has a special message for all of you. I'm going to turn it back over to him. I hope that you enjoyed tonight's math session. I hope that you join me again next week. The Olympics will still be going on, so maybe I'll wear my red, white, and blue again next week. Tell your friends who are prepping for these exams to join us on Wednesdays. And Dr. A, I am going to go ahead and turn it back over to you. Thank you guys for joining.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well. And on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.